satisfying. When a product is fun, the owner is much more likely to make the effort needed to carry out a repair. So, from the very beginning, the product should make people smile. When someone takes it out of the box and uses it for the first time, they should think, wow, this is neat. I want more of this. And the sights and sounds of a product are very influential. If we take a Herbert Terry Anglepoise lamp, a product of the 1930s, which was very popular with architects and draftsmen. If you hold the shade between your thumb and forefinger, you can move it anywhere, any place and any angle. And when you let go, it doesn't fall. It's held by the geometry and the tension in the springs. And this gives an incredible feeling of precision and balance. And if you think of a sewing machine, you can immediately tell if it's good or bad based on the noise it makes. A good sewing machine sounds solid and smooth, while a bad sewing machine sounds hollow and scratchy. So these sights and sounds have a huge effect on how the owner values and respects the product. People also love traditions. This is because a tradition gives you an anchor in time. You can learn from the past and pass on skills to the next generation. In Western Europe, it might be making chestnut stuffing at Christmas. In the Far East, it could be carving birchwood bowls and coating them with urushi lacquer. And people also love possessions which go together with these rituals. Maybe colourful enamel pots for cooking, or sharp chisels and gougers for woodworking by hand. And they like to buy these things from companies with tradition. That doesn't mean it has to be a long-standing tradition. People are also open to supporting a young company, an optimistic company that wants to start a new tradition. The designer should aim for a valuable relationship between the product and the owner. I've had this leather belt for 27 years. I was wearing this belt when I met my fiancée, when I first saw a vulture in the wild, and when I made this blackboard. So it has a huge number of good memories associated with it. And when the leather strap finally gives way, I'll save the metal buckle and fit a new strap so I can keep on using it, because it's a huge part of me. Lastly, people should know that the product is fair and honest. They don't want to feel held over a barrel by the manufacturer for expensive spare parts or consumables. And they want to be sure that the manufacturer treats their employees fairly, irrespective of whether they're nearby or halfway across the world. As an example, I've picked this carousel toaster made by Berda of Johannesburg. I found an advertisement for this toaster from 1962 when it cost £4, 17 shillings and sixpence. It's a sturdy appliance, it's made from chrome-plated steel, and it's highly repairable because it uses a standard coiled wire element, which was very popular in heaters of the era and which you can still buy for pottery kilns today. So you don't even have to get that element from the same manufacturer. And when it comes to fitting it, you just take off the top and wind the coiled wire around the ceramic column. But the best thing about this toaster is the way it turns the slices of bread. When you turn this knob on the top, 4 toast carriers open around the periphery. You put the slices of bread in, plug the toaster in, and then you keep on turning the knob to push the first side of the bread against the element. And you've got some control here. You have to keep an eye on your toast. You can adjust the distance between the slice and the element to control the browning and the rate of toasting. And okay, that requires some effort, but it's a nice antidote to highly automated products. And it's very, very difficult to make a highly automated product, which is also charming. And when the first side of the bread is toasted, you turn the knob in the opposite direction, and the carrier's open, flip over, and push the second side of the bread against the element. I've now swapped the chrome toaster for this. It's quite a rare edition of the same Berda carousel toaster. This one is finished in white vitreous enamel with a delicate orange clementine pattern burnt into the surface. It's also a very durable surface finish. And this toaster obviously meant a great deal to its previous owner. At some point, the Bakelite connector on the end of the cable has obviously broken. Now, you can debate this design detail. If you have a cable that's permanently attached to the toaster, then you don't have problems with the connector breaking like this. But on the other hand, it's then much harder to replace the cable if it perishes. And what they've done here is to retain the two brass sleeves out of the broken Bakelite connector. And they've then wrapped these in white heat shrink sleeving and put some white insulation tape around the cable here so that they can continue to use their favourite toaster. Now, the slice turning mechanism here is not what designers regard as creeping featureism. Creeping featureism means that unnecessary features are added to successive iterations of a product. But any toaster needs a mechanism to manipulate the slices. Either they have to go up and down, or they have to be turned so that you can toast one side and then toast the second side. And with this toaster, it's actually no slower than a toaster that does both sides at once, because it toasts the individual sides faster. And in this case, the mechanism is the key part of the design. It gives it a little magic. Here's a better look at the slice turning mechanism seen from the top. To me, it's like the petals of a flower, unfurling at dawn and furling at dusk. And if you stop at the midpoint, it'll keep your toast warm without burning it. But I do have one criticism of this mechanism. It's quite rough and noisy, and it would be more satisfying if it was smooth and quiet. The problem comes from the gears under this top cover. There's a large gear connected to the knob, and this meshes with 4 smaller gears on the tops of the toast carriers. And the large gear has a flange. This means that the whole weight of each toast carrier and the slice of bread hangs on the teeth of the small gear, which press on the flange. And when the gears turn, this means that the teeth of that gear scrape against the flange. Now, you can't put oil in a toaster. It would drip onto your toast and gather breadcrumbs. So the gears have to run dry. But for this purpose, steel on steel like this is not a good combination of materials. The mechanism would be smoother if one of these gears was made from brass, or if there was a simple thrust bearing provided underneath each toast carrier so that there was no weight pulling on the flange. Nevertheless, I'm quite sure that the reason why this toaster has survived for over 60 years is because this mechanism is incredibly satisfying.